sometimes we want to control the traffic flow at the IP address or port level, which is the OSI layer 3 or 4. Then you might consider using Kubernetes network policies for particular applications in your cluster. Network policies are an application-centric construct which allow you to specify how a pod is allowed to communicate with various network entities. They use the word entity in the Kubernetes documentation because words like services and endpoints are used for something else in the Kubernetes nomenclature. The entities that a pod can communicate are identified through a combination of the following three identifiers. 1. Other pods that are allowed. 2. Namespaces that are allowed. And 3. IP blocks. There are a few exceptions, however. A pod cannot block access to itself, and another exception is traffic to and from the node where a pod is running is always allowed, regardless of the IP address of the pod or the node. When defining a pod or namespace based network policy, we use a selector to specify what traffic is allowed to and from the pods that match the selector. Meanwhile, when IP based network policies are created, we define policies based on IP blocks, that is the CIDR ranges. By default, pods are non-isolated, that is, they accept traffic from any source. Pods become isolated by having a network policy that selects them. Once there is any network policy in a namespace selecting a particular pod, that pod will reject any connections that are not allowed by any network policies. Other pods in the namespace that are not selected by any network policy will continue to accept all traffic. What I mean to say is, if you have a network policy in a namespace and in that policy you specify a particular pod, that particular pod can accept traffic only from the entities which are mentioned within the network policy. Now let's discuss a simple example for a network policy. We will be just discussing the mandatory fields in the network policy. As with all other Kubernetes config files, a network policy needs API version, kind, and metadata fields. Network policy spec has all the information needed to define a particular network policy in the given namespace. Each network policy includes a pod selector, which selects the grouping of pods to which the policy applies. An empty pod selector selects all the pods in the namespace. Each network policy includes a policy types. This list, which may include either ingress, egress, or both. The policy types field, that is TYPES field, indicates whether or not the given policy applies to ingress traffic to the selected pod, egress traffic from the selected pod, or both. If no policy types are specified on a network policy, then by default, ingress will always be set and egress will be set if the network policies has any egress rules. Each network policy may include a list of allowed ingress rules. Each rule allows traffic which matches both from and port sections. Each network policy may also include a list of allowed egress rules. Each rule allows traffic which matches both the to and port sections. Let's just discuss the behavior of to and from selectors. There are 4 kinds of selectors that can be specified in an ingress from section or egress to section. The first one is the pod selector. This selects particular pods in the same namespace as the network policy, which should be allowed as ingress sources or egress destinations. The second one is namespace selector. This selects particular namespaces for which all pods should be allowed as ingress sources or egress destinations. Then the final 2 are namespace selector and pod selector. A single to/from entry that specifies both namespace selector and pod selector selects particular pods within particular namespaces. But be careful to use the correct YAML syntax. The next one is IP block. This selects particular IP CIDR ranges to allow as ingress sources or egress destinations. These should be cluster external IPs since pod IPs are ephemeral and unpredictable. Cluster ingress and egress mechanisms often require rewiring the source or destination IP of packets. In cases where this happens, it's not defined whether this happens before or after network policies processing, and the behavior may be different for different combinations of network plugin, cloud provider, service implementation, etc. In case of the ingress, this means that in some cases, you may be able to filter incoming packets based on the actual original source IP, while in other cases, the source IP that the network policy acts on may be the IP address of a load balancer or the pod's node, etc. For egress, this means that connection from pods to service IPs that get rewritten to cluster external IPs may or may not be subject to the IP block based policies. Now, let's end this with some of the default policies. By default, if no policy exists in a namespace, then all ingress and egress traffic is allowed to and from pods in that namespace. We have a few cases. We can default deny all ingress traffic. We can default allow all ingress traffic. We can default deny all egress traffic. We can default allow all egress traffic. And finally, we can also set up a default deny all ingress and all egress traffic. This is it for this episode. As always, if you have any feedback, questions, or just want to say hi, you can write to me at kubernetes@cent.com. I'll see you in the next episode. Thanks.